Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
All right, Al Martin back with you, podcast listeners, Making Data Simple. I love all the nerds out there just like me. We like to talk tech. Hopefully, it's the right balance of business, technical, fun. That's the objective that we try to do. Keep it light, go deep where we need to, that kind of thing. Today, I am going to talk about Tonic.ai. This is a company that's raised 35 million Series B, led by Insight Partners, to power a synthetic data platform that de-identifies, mimics, and fabricates data for development, testing, and AI workloads. We're going to hear all about it. We deal a lot with synthetic data, for example, to train models. So I'm going to talk to the guy that has a company that is built on synthetic data for AI and software teams. So this is perfect. So I don't know. I guess the topic today would be like synthetic data for AI and software teams. Maybe a working title would be how to build AI on safer, smarter data. Or we could even make it a little bit more fun and say from data protection leaks. Let's see if I can do my movie voice. From production leaks to fake data, fixing AI's risky foundations. Anyway, I've got Adam Kamor. He is the co-founder and the head of engineering at Tonic.ai. I welcome you here. We're going to have some fun today, Adam. Thank you. Again, pleasure. I would ask you to start by introducing yourself, if you would.
Certainly. My name's Adam. I am from and currently live in Atlanta, Georgia. I've been here my whole life, besides a quick 4-year stint in Seattle, Washington. Out of grad school, I went and worked. What's that?
With that? You said to hell with all the rain, or what?
The hell with all the rain, but more importantly, I like Seattle, but I like being around my family and friends more. My wife and I decided to move back to Atlanta after we had our first kid. We moved out there always knowing it would be temporary. I just did it out of grad school. That's where I got after grad school, I was ready to make money. So I just took the offer with the biggest dollar amount on it and just kind of, went where it took me. But back in Atlanta now, I've been back for, 8 or 9 years and, couldn't be happier.
So I knew you were a dad. You know how I knew you were a dad?
How's that?
Because you have a hat on that says dad.
Yes. Straight into the point. I got 3 kids.
Yes.
Yeah.
There's no ambiguity there. It's just
no, there's not. I'm not sure where I got this hat from. This is not a hat that I would buy, but I actually assumed the podcast would be video recorded today, and I need to go get a haircut, and I haven't. So I'm like, I'll just put on a hat, and this is the first one I could find.
I've thought about putting it on the YouTube. I did a couple of them, but it was just like kind of a pain in the ass. So I decided, no, it's better. I find people are more free to really just give their views if they don't feel like they're being recorded for some reason. It makes it too formal or something.
Yeah, I get that. I cleaned up my whole backdrop right before this. There's like a table behind me. I did one of those things they do in the movies where they clear everything off with just swiping their arm across it. So I had to do one of those right before the call started. Not knowing.
My wife will thank me. Tell her that she's welcome. She's welcome.
Well, it's now all on the floor, but yeah.
Well, never mind that. Never mind. Yeah. We'll take that back. A father to 1 kid or 2 kids? Or?
I have 3 children.
3? Yeah.
Yeah, all young. Yeah, it's good. The oldest is 8, the youngest is 3. So we're, in the thick of it right now. And then, of course, I had my 4th child, Tonic.
Yes, of course. We're getting there.
Yeah.
By the way, when they get to be teenagers, that's when you're in the thick of it.
That's the thick of it. I've always heard, bigger kids have bigger problems. And, I think that, I see some truth to that.
All right, look, so what's your history? I mean, what's your training? What'd you go to school for?
Sure. So I graduated from Georgia Tech in Atlanta in 2009 with a bachelor's degree in physics. And I ended up staying at Georgia Tech from 2009 to 2013 to get a PhD. So I have a PhD in physics from Georgia Tech. My area of focus was on something called nonlinear dynamics. These are dynamical systems, systems that are changing and they're in motion one way or another. And there's typically factors in the system that lead to nonlinear behavior. In less technical jargon, you would call this chaos theory. So nonlinear systems, nonlinear dynamics, it was more of a focus on, chaotic systems and chaos theory.
Wow, that's a lot, man. So did you have to take theory of relativity? Yes, of course you did.
Well, I did, but never at the grad level. You had to take these types of courses in undergrad. And I'll be straight with you. Look, my understanding of that stuff is maybe better than the layperson, but it's by no means much better. Think of in undergrad, you're kind of like knowledge. I'm using my hands to explain this, but your viewers won't be able to see it. So I'll try to paint a picture with words. In undergrad, you kind of imagine your knowledge when you enter college as a point. So in undergrad, you get your degree in physics. Now the point becomes a circle, right? It's kind of expanded in many different directions because I'm learning many different things. But when you get to the PhD level, it doesn't expand in a circle anymore. It expands in like a line radiating perpendicular out from the circle, like a spike, right? Because, you're so focused on just one thing, and anything outside of that thing, really, you don't know that much about. I know one little sliver of physics, and I know it very deep, but it's a very narrow sliver. And general relativity is not in that sliver. Does that make sense?
It makes total sense. I have to tell you, though, the one reason why I asked that is because I am just dumbfounded by the fact that an electron can be a wave or a particle.
Yeah, that's right.
And we can't explain it. What's your explanation? That's what I want to know.
Well, you just said you can't explain it. Now you're asking me to explain it.
Yeah, well, I should have said it. Well, I'll cut that part out. Just tell me what.
So no, I can't explain it. It's called, what's it called? It's called like wave-particle duality, where the way I see it is, sometimes you're trying to explain some phenomena, and it makes more sense to kind of describe the thing as a particle. And in other situations, you're trying to explain something else, and it makes sense more to explain it as a wave. So, think of them as just like, different models you can use to explain the world around us. That is how I typically like to think about it. I actually, interestingly, I worked in nonlinear dynamics, and that's understanding nonlinear systems, chaotic systems. But the specific system I focused on was actually a system with electrons in it. It was from atomic physics. The physical setup would be described as you have like a gas of some molecules, maybe argon atoms. So I said molecules, I meant atoms. So maybe you have a gas of argon atoms or hydrogen, molecules, something like this, and you shine a very strong, very fast blinking laser at it. What happens? And it turns out the laser field interacts with the electrons in a way where typically they'll ionize, meaning the electrons will be ripped from their atoms or molecules, and they'll just kind of go off and go away and never come back. And that interaction right there is purely a quantum mechanical interaction. So you would be concerned with waves and particles and all of these things, but we actually modeled the system as fully classical. We treated the electrons as particles. And we were able to very well describe the experimental results with our theoretical models that were incredibly oversimplified. And it worked. So, in that situation, we actually did treat the electrons as particles. They're not necessarily that, but we treated them that way. And we were able to perfectly kind of like, explain and mimic and reproduce experimental results. So it works is the answer.
The thing about so look, we're completely off the rails, but people will enjoy this. I just find it amazing that the act of observing an electron forces it to stop. Just the act of observing forces it to stop behaving as a wave, and then it looks like a discrete particle.
Yeah, it's the act of observing it kind of, we'll have to kind of pin down certain properties of it. The most interesting, maybe not the most interesting, but if anyone's kind of interested in this at like at a very high level and just wants to kind of have their mind blown a little bit, go look at Stern-Gerlach experiments. These are experiments where they would observe electrons to understand their spin. Electrons have a spin either up or down. Yeah. So you can go check out the Stern-Gerlach experiments to just see some really interesting and fun properties of electrons and what it means to observe them in quantum mechanics. And man, it's been at least 15 years since I thought about that. I hope I'm remembering this experiment correctly. I'm pretty sure it's the one.
So far, you're hitting it. You're legit. The thing but then carry this one last point forward is there's a lot of people that think like we could be in a multi-universe.
Oh God, I have no idea.
Well, I think we're splitting off, and that's why it's different.
I'm a software engineer. I don't.
All right, fantastic. So that's a good pivot. So let's take it back a little bit. Thank you for that. See, that's why I asked your background. I'm talking with a physicist. This is awesome. How do you get into software engineering from being a physics major? Let's go there first, and then I want you to give me the definition of synthetic data, because that's what
So how did I get into it? Man, okay, so I graduated with this PhD. I start looking for jobs. When you graduate with a physics PhD, you have there's a few well-trodden paths. Okay, one is to go do a postdoc. If you do a postdoc, the assumption is you're kind of trying to get into a full-time research position or tenure track at some university or maybe national research lab or something like this. So that's kind of option one. Stay in academics. That is a very hard path. I was smart enough to know I wasn't smart enough to get tenure track anywhere. So I'm like,
it's smart. You know that.
It's pretty smart. So I was smart enough to realize I couldn't do that. So I'm like, okay, this path isn't for me. I'm like looking at like the professors in the physics department. I'm like, oh my God, these guys are just off the charts. So I'm like, okay, that's not for me. So, the other paths that one typically found, this is back in 2013. I bet things have changed a little bit since then. A lot of guys would become quants on Wall Street, quantitative researchers, high frequency trading, Black-Scholes, all of these types of things. right? The other path was, some combination of like either software engineering or data science. Of course, this is before LLMs were on the scene. So, a lot of the data science is more predictive stuff, forecasting, things of that nature. But, those were open options as well. And I actually took a job at Microsoft in Seattle as a like a product program manager type role, working in the Windows, ecosystem.
Mhm.
And I enjoyed it. But, I did it for, maybe like a year and a half. And I really was unhappy with how not technical it was. So I kind of wanted to get back into technical stuff. So I ended up kind of, moving to a different role at a different company, ended up, kind of transitioning there to software engineering. And I've stayed in software engineering ever since. And, I'm not a classically trained software engineer. I didn't go to school for it necessarily, but I've been programming, I think, probably since I was like 10 or 12. I did a lot of it during my PhD. Like a lot of the stuff that we had to solve for and analyze was typically done numerically because the equation is going to be solved by hand. So it's a lot of number crunching. I was doing work with CUDA, using their C99 equivalent implementation back in the day before PyTorch was a thing. And I've been kind of doing that kind of work ever since, and I really enjoy it.
Nice. That's a pretty good transition. All right. So speaking of transition, give me the definition of synthetic data. I mean, most people should know that out there. This is the Making Data Simple podcast. So give me your definition of synthetic data.
Yeah, it is not. That's not a simple question. And I say that because I'm on calls with customers all the time where everyone on the call, they're kind of like opinions. Everyone has one. Everyone has their own definition of what synthetic data is. So typically on the call, I like to kind of put a stake in the ground and say, when I talk about synthetic data in the context of, this product that I'm working with you on, here is what I mean. So I'll give two definitions, and I'll say where we focus primarily and et cetera. So definition one of synthetic data. Synthetic data is like using some technique to look at real data, to understand the relationships in it, to understand how this relates to that and the meaning of this over here, et cetera. And then at that point, you kind of discard the data, the real data, discard it. But you get to keep your model, your understanding of these relationships. And then from there, you can begin generating new pieces of data. So for example, if this was structured data, I might use my understanding to kind of analyze a table, understand the relationships and the ins and outs, discard the table. And then when someone comes to me saying, hey, give me a synthetic row of data, I kind of essentially sample from this model that I've built of the real data and generate a new row. This new row isn't associated back to any original row in that source table. It's more just generated from our understanding of relationships. So, I can't tie it back to an individual in the source data set, more just to the kind of statistical relationships I'm able to kind of ascertain. Okay? So that's essentially building data from a model, from nothing almost. Analyze data, discard it, then generate data that looks like the original. That's one definition, right?
All right, I got
the definition, though, that I typically use, and when we talk about synthetic data at Tonic in general, but there are exceptions to this, we typically take real data. We identify the parts of the data that are identifiable to individuals, the sensitive pieces of information. We synthesize just those pieces, and we do it in a way where the semantics and meaning and relationships are still preserved. And then the new piece of data you get is structurally, schematically, semantically identical to the source, but there's no user identifiable information in there. So as a result of that, you end up with very high quality pieces of data. They can't be tied back to individuals. If you work in finance or healthcare, there's very specific rules as to what you have to do to work with this data safely. Think of HIPAA in healthcare, right? And then with this data now, it's highly realistic. It's safe. It's actually very well understood how it's created in general, and you can use it. So that's typically the definition that I go with, which is not what people expect most of the time.
But just to be clear, what was the need in the market you saw? Obviously, we need synthetic data, but you thought the need was so great, you said, hey, look, I'm going to go found this company, Tonic.ai. So why is that? What made that determination, and where do you make that transition to say, all right, I'm going all in?
Understood. So we started the company in 2018. So I want to give that context. This wasn't started 2 years ago after OpenAI became a household name or something like that. So we started the company in 2018. For a while. We have 70 some employees, hundreds of customers. We focus mostly on the enterprise. We've been around the block. It's not a fly by night type thing. In 2018, the problem that we were specifically focused on was how to generate synthetic data for application testing and development. Imagine the pain that the developer has. They're developing or testing a new feature, or they're fixing a bug, and they need data that looks like their production data so they can actually do their job effectively. The first product that we built, called Tonic Structural, is still something that we sell today very actively. Tonic Structural takes an application database, creates a synthetic or de-identified version of that data. It's structurally and schematically identical to the source. but it's now devoid of sensitive information. It's dropped directly into your dev or staging environment. Your applications can immediately connect to it so that you can start developing and testing. Nothing to do with AI, nothing to do with data science or analytics. It is a product that helps software developers have access to real data or data that looks real so they can do their jobs more effectively. That's how the company started. Nothing to do with AI, believe it or not.
But I know you and you've repeated that like 3 times, but I presume the good news is for you is AI just amped that up when it came.
So here's where AI comes in. Okay, so like, God, I'm so bad at these timelines. Probably it's like 2 or 3 years ago. I don't customers start coming to us saying, hey, can you do this with unstructured data with text? Everyone at the time, and this still remains mostly true, they're trying to either build RAG systems, inference foundational models like, OpenAI or Anthropic, or they're trying to fine tune their own models or even build their own LLMs from scratch. But to do this, they need data. Okay? And actually, there's 2 groups of people that need data. The companies themselves that have their own customer data, but it's too sensitive. But also LLM foundries need data, and we should talk about that at some point. But so anyways, these customers are coming to us being like, hey, I'm trying to fine tune a model. The data I have, I can't use because it contains customer information. Like, here's a good example of that. Imagine you're an EMR system trying to fine tune a large language model to provide better patient medical history summaries, right? Like, you want to summarize the patient's medical history to give it to the provider before they walk in the room. You want the summary to be good and accurate. EMR systems have incredible training data here. But if you go fine tune a model and include customer PHI in the weights of the model might regurgitate information about patient A to the patient B, right? So the trick here is you cannot actually include PHI in your fine-tuned data. You got to synthesize it first. So we start this new product called Tonic Textual. Tonic Textual can synthesize unstructured text. We find what's sensitive, and then we can replace it with highly realistic synthetic values. Okay? We do this for raw text. We can even synthesize things like PDFs, Word documents, images. We can really do, wherever there is spoken or written word, we can typically either purely redact it or we can synthesize it. And primarily we do this for like model training purposes. And that's what customers primarily use Tonic Textual for now. But it's not just our customers that are trying to fine-tune their own models that need this kind of stuff. Large language models or rather the companies that build large language models are incredibly data hungry, like incredibly so. And at this point, they've kind of already ingested all of the data that's openly available, right? Okay, they've ingested all the forum posts and the Wikipedia pages and like all of the open data on the internet. So what's left? Well, what's left is the data sitting behind company firewalls. So you're starting to see companies pop up that actually will kind of provide this type of data to these LLM foundries, and essentially they sell it. Before they sell it, they have to make sure that they're adhering to ethics and compliance and privacy regulations.
Tonic.ai, are you like a gin drinker? Where does Tonic come from?
Everyone always expects a founder to have some really cool story about how they chose the company name.
Yeah. And
the reality is there's not many domain names available. So you kind of take what you can get. I don't like gin. In fact, I hate gin. Tonic.ai was available. Tonic.com was not. So we're like, all right, I guess we'll go with Tonic.ai. We didn't want some company name, which is like a bastardization or misspelling of some common name, like spelling phone with an F or something like that. Because I feel like that just kills your SEO and ability to find you on Google. So Tonic's a simple word. Everyone knows it. The domain was available. We went with it.
You were watching somebody drink a gin and tonic or something?
No, I'm telling you, there's no cool part to the story. I wish there was. Yeah.
You need to make one up, dude.
Yeah, now it's out there. I'd be a liar.
Going back to synthetic data, here's what I know. I'm going to tell you everything I know, and I want you to debunk some of the stuff that I know or don't know. All right. What I know is that the cool thing about synthetic data is like we need it today for all the AI mentioned or reasons you mentioned. It is interesting, and I think that's key to your story or narrative that you started in 2018. Because that's a different element than I think most would think. It's different than I would have thought, right? But no real people. The good news is you can reduce privacy risk. So that's good for like financial regulations, HIPAA, GDPR, all that good stuff. Data availability, you can generate as much data as you want, right? You can fill gaps with real data that may be on edge cases, rare events, whatever, have balanced data sets. In other words, you can take things like from fraud, whatever. You got that. You can do faster experimentation. No long data collection cycles now because you can enable rapid prototyping. There's cost efficiency, reduces expensive data labeling, right? You can cut your dependency on third parties. And you can also have some bias control. You can look at things to make sure you're testing for fairness. what if scenarios, whatever. How am I doing so far? So far, so good.
Those are all very nice selling points. But
I'm going to get to the cons now.
Well, I want to disagree with one of your points.
All right, hit me.
Real quick. You have made the assumption in synthetic data that essentially it is generating it just via some understanding of the real data so that you can generate an arbitrary amount of it. We actually have products to do that. So we can do that. So for that type of synthetic data, yes, you're absolutely correct. And your listeners should check out Tonic Fabricate, which generates data from scratch at arbitrary amounts with arbitrary distributions. It's a really cool product. But for Tonic Textual, with your unstructured data, it's typically one record in, one record out. It's not just generate as much as you like. So some of those points aren't valid for the Tonic Textual products.
That's good.
I hesitated to bring it up. I feel like it's more of a...
No, you should. This is what I want. This is exactly what I want. I would see that as like, the selling points or whatnot. So it's great that you're already hitting stuff. But here's some cons that I want to throw at you. And I want you to debunk these or whatever. One is synthetic data can be typically only as good as the model that generated it. It can miss some real world correlations. So you could be training in a fantasy land of sorts. If you do have bias, it could actually amplify those biases. So it'll exaggerate because it could reproduce. Models that are trained, going to models, or that are trained heavily on synthetic data may overfit to synthetic patterns. In other words, they'll underperform on like messy data. I think validation can be hard. Like, how do you explain that behavior to regulators or auditors in terms of how you came up with this data? Complexity. Look, doing this, of course, you figure this out, isn't trivial. You've got to have domain expertise sometimes. You've got to have strong generative models. You've got to have ongoing monitoring. Now, I do think like it shines in like fraud detection, financial services, healthcare. But look, if you're trying to reproduce like specific subtle correlations, that matter more than volume, maybe that can be more difficult. Let me pause there. What do you think? What's
I agree with everything you just said, and and it's worse. It's worse than you're saying. Many of those problems are not currently insurmountable. Are currently insurmountable. They can't be solved right now. Even worse, some of those examples you gave at the end, where you're like, oh, but it would shine in fraud detection. Where there's class imbalances, so you need to generate more data of a certain class to balance things out. It doesn't shine in that. So it's, yes, I agree with your cons, and actually it's much worse than you said. So, look, you're then like, well, Adam, what the hell are you selling people then? Because because those are some pretty serious issues. And again, because of those reasons, that is why when we synthesize, here's what some people want to do. They want to look at an application database with its thousands of columns and hundreds of tables and say, hey, let's train a model that understands all this stuff. And then we can just go inference the model and generate as much data as we need. And we can tell the model, hey, bias this way or bias that way or give me that distribution. That is a pipe dream. That type of synthesis is not possible at that scale of data. It is, if you want to know why, it is simply an issue of dimensionality. So I'm going to give a very hand-wavy explanation of this, and I promise it'll be quick. Typical embedding models for large language models, like the Da Vinci from OpenAI, it's on the order of 1,000 elements in a vector. So it's a vector dimension, maybe 1,000. Take your typical application database table. Maybe it's a demographic table, which is a trivial table. It's got, name, address, age, things like this. How do you embed a row of that data in a vector, right? For every single unique value in each column, you have to add a dimension. So first name column, millions of names. Great. Addresses, millions of names. States, there's 50. Ages, there's, maybe 100, right? Mm-hmm. Even in one little table, you end up with these embedding vectors that are massive, dimension tens of thousands or more, right? Yeah. So that's the hand-wavy dimensionality problem with this approach. And everything you said kind of assumes when we say synthesis, that's kind of like, we're taking an approach like that. We build a model that understands everything and we can just sample or inference the model. But that's not how we do it. Right? On the unstructured side, again, we identify sensitive information within a given document. We give you back a new document where we've replaced the sensitive info with fake info. It is not looking at 10,000 documents, inferring relationships, and then spitting out new documents that aren't related to the original. Our approaches are typically one doc in, one doc out, one row in, one row out. So that way, we can synthesize the few pieces of information that are necessary while avoiding this dimensionality problem of trying to synthesize all aspects of the data, even the parts that don't really matter.
But then you also have the opportunity to fabricate data if you need to, but you're saying you don't have to do that.
So we can fabricate data from scratch. We have a really slick product. It's brand new. It's called Tonic Fabricate. For those of your listeners that are familiar with Makaru, which is a pretty popular, free or almost free offering for generating data from scratch, it's built by the founder of Makaru, who has joined Tonic. Tonic Fabricate essentially gives you a natural language interface where you work with an LLM, with an agent rather, to kind of describe what you're after, and then you and the agent together kind of craft these data sets. And it's really, really cool. It's a really, really interesting take on data generation from scratch. I would we've heard it described from the users of it as like it's like the cursor for data, and that's when you need from scratch. But of course, the statistical relationships that it'll be able to generate perhaps won't be as nuanced as the real world. LLMs will do a pretty good job at like coming up with all of these interesting cases, but no, it won't be perfect. And if you do want that nuance, if you are trying to like train models, typically you'll use the approaches that I said, where it's one data point in, one data point out, operating on just what's necessary.
Carry that a little bit further. I mean, some of it I can infer on what you said, but specifically, where is Tonic.ai differentiated? There's other solutions, as you already mentioned, a couple, even open source in the community. Where does Tonic.ai shine?
Sure. So there's a few things. I'm going to speak just of Tonic Textual for a second, which is our unstructured data offering for synthesizing documents, text, etc. First point is our models for entity detection, which is kind of like the first step in this process, are absolute state of the art. They kind of exist on a level where no one else can really compete. You can take open source models like Spacey for PII detection, and Spacey is like trained on like Wikipedia pages and common crawl data from the internet. It doesn't really work with real world data in general. It's not that good. Even if you compare like our NER models with like the results of prompting frontier large language models, we'll outperform them on entity detection quality. But more importantly, our models are small burp models that you can run on cheap hardware. Go run our model on the cheapest GPU in AWS, like a T4, something like that, 40, 50 cents an hour, something like this. Process maybe 100,000 words per second. So, the models are cheap and blazingly fast. Our customers come to us with billions, hundreds of billions, trillions of words. You can't feed this stuff into large language models. It'll cripple them, right? But, our stuff can run on, cheap GPUs and process blazing fast. But beyond all of that, beyond the quality of the models and all of the work that we put in to synthesize realistic text, which is a lot of work that we put in, more importantly, we focus primarily on larger companies. Larger companies care about that technology as much as they also care about the workflows that we enable. Things like the auditing and the being able to share and RBAC and integrating with SSO and just having all of the essentially control knobs needed by large enterprises so that they can kind of check the boxes and do their job in the constrained system in which they operate. I'm not sure of a better way to word it. So I think we really excel because our technology is great, but we also deeply understand enterprises and kind of the world in which they live and what tools need to look like to kind of fit within their workflows.
You said this may be high level, but I'm going to ask it anyway because you may have a lot to add here. If you were to geek out, if we're talking Tonic Textual, how does it look like under the hood? I mean, what is it doing that really separates itself from a technology standpoint?
Sure. So the two big things are on the, and this will all be on the data science side. First, it's a set of NER models that are very good at finding entities within text. I didn't tell you what NER is. Let me say it now in case listeners don't know. NER is named entity recognition. It's a subset of natural language processing. Essentially, you give it a sentence and it tags entities in the sentence. Typically, the entities that we support are ones related to humans and organizations, and typically they're going to be associated with PII or PHI, like personal information, right? So for example, I give it the sentence, my name is Adam, I live in Atlanta. The model should correctly identify that, hey, Adam, that's a first name. Hey, Atlanta, that's a location or maybe even a city in which the person lives, right? So that's the first step. You got to kind of identify everything. Okay, well, you identify it. How do you actually synthesize new text? Imagine a complex sentence. I'm on the phone with customer support. Oh, yeah, my name's Adam. And they're like, oh, how do you spell that? Oh, it's A-D-A-M. Oh, sorry, was that M or N? And then I say M as in man, right? That long utterance, most of that was related to my name. When I say that name Adam, when I spell it, when I say M as in man, when they say, was that an N or M? Those are all parts of my name. So we can identify, NER will identify all of those things as being related to my name. But when you go to synthesize, how do you synthesize that in the correct way? Well, you want to replace Adam with John. When he spells it out, you want to spell John. At the end, they say, sorry, was that an N or M? And you say N as in Nancy, right? Now, because it's an N, not an M, right? Yeah. So being able to correctly identify all of that and then synthesize new text so that it maintains the same semantic meaning and intent of the original is a very challenging problem. And that's where we focus. And identification of PII is only half the battle. The other half of the battle is being able to synthesize it correctly. And we spend equal parts on both, frankly. And that's why we're very good. We're really good at generating the best quality data that contains no PII or PHI that you can use to train models. Because better quality data, better models.
Who's your biggest competitor right now?
Good question. Our biggest competitor is people incorrectly believing they can build this themselves. So then they do it, and then they come back like 6 months later, and like, okay, we're ready to buy. That's our biggest competitor because, first of all, it's a very fun problem. Engineers, at least good engineers, love building fun stuff. So people see this, they're like, oh, we can build this internally, we can do it, and they probably could get most of this done by using an LLM. Like an LLM will do a decent job on a lot of this. It won't do as good as our models will do, but it'll do a good job. But then you start hitting problems immediately. There's always hallucinations. They're hard to deal with. The scale of data that most large companies have, they can't feed it all through an LLM. It'll take forever, right? And so eventually they come back and they're like, okay, we're ready to buy. So I think just our biggest competitor is, I don't know, just people trying to build.
It sounds like it might be an LLM. Do you worry that LLMs, as they get better, that they're going to take away a lot of
Oh, certainly. That's all. I think anyone that isn't concerned about that for whatever their product is a problem. Or they're a fool, rather. I was reading this article from, it was Steve Yegi. He's like a very well-known, developer. He's worked at most of the big tech companies. And he's got, I don't know the name of his article. If I did, I would say it. Or I don't know the name of his blog. If I did, I would say it. Not that he needs traffic from me. But he was talking yesterday. Most SaaS companies can be replaced by an engineer just kind of like vibe coding an internal solution. Like it's going to get to that point where like, oh, I'm not going to pick a specific vendor, but like, I don't need this solution. I don't need to pay for it. We can literally, one engineer could build this in a few days with Claude Code. It won't be as good. It won't have as many bells and whistles, but we don't need all of that. We just need that subset anyways. So they'll just go build it themselves. So I think like that right there, people just kind of like vibe coding their solution is going to be a threat to a lot of SaaS companies. I don't think we're excluded from that. I think large language models are a far way off still from being able to operate at the scale necessary to process data like we do and also to do it as well. That's why you also need to kind of come up with other value adds. Like we don't just sell a model, we sell an entire platform where you can kind of like process data, view results, audit, analyze, make manual redactions, do human in the loop workflows. Like there's a lot more to it than just the models. And I think it's important to have that stuff. Otherwise, yeah, you're going to get replaced by some 23-year-old kid vibe coding something that works.
Totally. I totally get it. Is there a use case that you've experienced that I think would surprise the listeners? I mean, something that that's just completely out there that nobody would think, hey, I'm using synthetic data in this form?
Here's a cool one. Yeah. We can synthesize PDF documents. So take a set of PDF documents containing PII of some kind, maybe like legal contracts, financial invoices, something like that. We can create synthetic versions of them, and customers use them to train their own vision models. I love that use case because people don't assume you can do a lot with PDFs because the format and what they are under the hood is just so gnarly, especially if it's like an arbitrary PDF that you didn't create. We're able to work with those in a way that can actually give visually correct looking synthetic PDFs so that you can actually accurately train vision models. And when I found out the customer was doing this, I was just so pleased because I think it's a really cool use case, and it kind of shows like, it's like a combination of all of our capabilities. It's got the synthesis, it's got the NER, but it also shows our ability to like deeply understand these file formats and kind of deal with them really in whatever form they are.
Synthetic data is often seen as the silver bullet many times, particularly in the LLM world we live in. Where would you say it absolutely does not make sense?
We tried for 2 years to build a fully synthetic structured data offering. This is basically that pipe dream I told you about, where you look at a full application database, you build a model that understands everything, and you can inference the model. Our goal was simply to improve F1 scores of a fraud detection model. So it was the fraud detection use case. We spent
both of my things, yeah.
Yeah, we spent 2 years, about a year and a half maybe, trying to build that. Smart people, and we had 2 guys with PhDs working on it. We put some resources into it. We could never beat simpler techniques like SMOTE, which is SMOTE essentially generates more of the minority label in the classification data set just by kind of interpolating between points. That's all it does. Couldn't beat it.
You don't think anybody can do it?
We tried very hard, and I think we're very good at working with data and understanding synthetic data. We were not able to. I have seen people look. We could construct situations in which it performed better than SMOTE. Okay, I'm not saying we couldn't do that, but for generic data that we hadn't seen before, I don't think we could ever do it. I don't know. I don't think synthetic data is great for this class imbalance problem in structured data. I think there are just much simpler techniques that work. So that's one example.
Do you have another one, or you just that's probably the best one?
That's the one. I don't even know if that's the best one. It's the one that came to mind, and I don't want to make your viewers listen to 10 minutes of silence.
That's all right. So let me ask you this. Earlier, you mentioned, and look, this is what I think everybody thinks of. Probably listen to this podcast because everybody's thinking AI right now, is the LLM boundaries that need data. You had a visceral reaction to that earlier on, saying, well, we could just go into so much detail on this. We're going to bore the hell out of everybody. Say a little bit more on it. Why did you react that way?
Yeah, because I think the best way to continue to improve LLMs on the trajectory at which we've kind of seen them improve in the past is to get them more data. I think there's decent evidence at this point that just increasing parameter counts only gets you so far. You need data. Well, the data they need is the data they can't access because it's sitting behind company firewalls. So what do you do about that? Well, you're starting to see a lot of vendors out there that are essentially providing data sets to these large foundries so that they can train more. It could be like healthcare data sets that go through like a safe harbor or expert determination to make them safe. It could be any type of data. Just healthcare is one example, right? So I think we are entering like this world where everyone's going to be very data hungry. Either they need data to keep training, or they have data but they can't use it until it's made safe because the LLMs that are out there trained on open data are only going to go so far. So that's what I think is going to happen. It's going to become more true as all of the new data being added to the internet is LLM generated. So that can't train on that really. So I think there's kind of one untapped data source left, and we're going to have to deal with it. And privacy is going to be the main concern, and it's going to have to be dealt with. And I think we are at a unique position to help with that. So that's why I'm excited.
Seems like you're excited. I can tell the passion that you have. That's awesome. I mean, you got a lot of energy. That certainly comes out. Is there any question that I didn't ask you, wish I would have?
No, I think you covered it all.
If there's any one thing that you'd leave the audience, I mean, just a real short, what should they be thinking about as they walk away from this?
Yeah, if you're going to start, if you have sensitive data that you want to use for model training or testing and development or some purpose, it'll behoove you to figure out how you're going to access it and deal with it before you kind of get too deep into the project. There's a lot of solutions out there. You can certainly start with open source. Maybe that'll work for you. It could. But if not, you should consider Tonic. And you can check us out at Tonic.ai.
Tonic, that's what I was going to ask next. So where to reach you? Tonic.ai. Where can folks reach Mr. Adam?
Well, I'm not going to give my email address. That seems foolish. Find me on LinkedIn.
LinkedIn.
I think there's only one. I think there's only one Adam Kamor. So you can find me there. No problem. Right. And come and say hi. Tell me you heard about me on the podcast. That'd be fun.
Yeah, flood is LinkedIn, everybody. That's what you should do. That would be great.
Just like all my posts, please. That's all.
Fantastic. What do you do for fun, man?
And that's what I should have asked you to ask me. I am extremely passionate about working on cars and to a lesser extent motorcycles. So I like working on old cars or even newer cars. I have a 1968 Mustang, which I restored from basically a rust bucket to something that is, better than a rust bucket. Looks pretty good.
What's that? All by hand.
All by hand. I didn't do the body work in the paint. I'm not set up to paint a car in my house. That old paint on these old cars is very toxic. You kind of have to do it in the correct environment. I got kids at home. I don't want lead dust everywhere. So everything but the body work and paint, I did myself. And then about a year ago, I bought a 96 Mustang with Ford's, at the time, new 4.6 liter modular V8. And it's got a roll cage in it. And we're going to try to race it as part of the Lemon series of racing. It's called the Lemon Race. It's basically a 24-hour endurance race. There's maximum caps to what you can spend on your car. So it's meant to be a thing where an average guy can do it without breaking the bank. The richest person isn't necessarily going to win because he can't spend more money. So it's a fun, cheap way to race. And I'm looking forward to doing it with some friends. I just got to get this car running. I bought it. The motor was basically busted with a terrible head gasket leak. Just dropped a new motor in from an 03 Ford Explorer. It starts up, it runs, but I haven't really kind of, tested it too hard yet. So I got to do that as soon as it warms up a bit.
What's your favorite car of all time? Or what would you like to be fixing up? If you had a chance.
Yeah. No, it's a good question. I'm a sucker for the 70s and 80s era 911s. I love the 70s and 80s era 911s, the Porsche 911. I think that body is, I think they're incredible looking. They're so cool. I'd like one of those. I like the Buick GNX. I like those a lot. The Grand Nationals. I think a lot of people don't think they look good. I love '80s stuff, and I think they look neat. I'm not necessarily a child of the '80s. I was I don't really remember the '80s. I was too young. But that car I just really like.
I am a child of the '80s. I hate to date myself. I didn't really like the looks. That's interesting of the Grand National for some reason because it looks too much like some earlier cars. So I can remember them showing me this car, the Grand National, and saying this thing is the fastest car on the planet. And I, as a kid, I didn't know anything about it, but I'm looking this thing over, and I can still remember that. It was a black Grand National.
Yeah. My like on it is more just the look. That's funny though. I think they look great. My favorite motorcycle is a Honda V65, which also is a very divisive looking motorcycle, but it was the fastest production motorcycle when it was made in the late 80s. It's got this super ugly square headlight that most people revile, but I think looks just so cool in the 80s. So that would be my favorite motorcycle. I've never owned one because they're impossible to get because they all had these cooling issues. So in most of them, the engine head would overheat and kind of like just become useless. So there's not many of them. So they can be a bit hard to get, but they're super cool.
The other ones I would say is like an old Chevy Camaro. I used to love those things.
Have you? I don't know if you checked used car prices. The price of those like muscle cars from that era.
Yeah, going through the roof.
They're through the roof. Absolutely.
I always wanted like an old Vet Stingray, even though
those get pricey real fast. Look, you know why I chose the Mustang? There's tons of muscle cars from this era. The Mustang was, technically, I think it was called a pony car, not even a muscle car. But I bought that '68 Mustang because they made a million of them a year back then. Yeah. So they're cheap, It was like one of the only like cool cars from that era I could get without just absolutely breaking the bank.
Dad, back in the day, he had one of those. Well, not a Mustang, but he had the Chevy Camaro. Drove it as fast as he could one time. He wanted to see how fast he could get it. He kept hearing this rattling. He's like, what the hell? Kept hearing the rattling. He'd slow down and quit. He'd go faster, rattle again. All of a sudden, the rack on top of the car flew off. Just came off the whole thing with the bolts and everything. Yeah. He's like, oh, found the rattle.
Probably ripped some holes in the sheet metal.
Yes, it did. It did. Yeah. It ripped holes right out of it. You can see all these holes at the top. Yeah. He's like, that's what it was.
If he knew what that car was worth today, he would have been a little more careful with it.
He never got rid of it. Well, hey, man, Adam, I appreciate you being here. This was a great discussion. Thank you for blessing us with your presence today. It was awesome. And one of the cleanest desks I've ever seen. Really nice.
Thank you. That's funny. Thanks. Pleasure to be here. Thanks for the invite. I appreciate it.
All right, fantastic. Adam Kamor, everybody. And as always, I always got to end it this way. Hit us on almartintalksdata@gmail.com. Love to hear from you. Until next time, we'll see you on the podcast. See you all. Bye-bye.